this video, I'm going to be talking about the steel structure that you will be adding to the second project in our Revit work. So before we get into the details of Revit, I want to also talk a little bit just more conceptually about the design of a steel structure. So the structure that we'll be adding in Revit, there's some things about this particular diagram that we'll be kind of borrowing, and you'll see that as we begin to place some of the components. But basically the idea is that we have columns. Turn on the highlight tool. We have columns that are made out of wide flange steel members here and here. We have girders that are spanning between those columns, and we have some joists that are taking the majority of the load from the floors. On top of it, and we won't do this in this session, there is a concrete slab that's sitting on corrugated metal. Okay, so that will come later. But basically, the columns, the girders, and the joists are part of the assembly for this assignment. Some of these details about the spans are going to be different. You know, we're working with a 25-foot span, and so some of this information is irrelevant, but you can kind of get a big picture idea of what we'll be drawing. I also want to show you, I'm a little embarrassed to say this is a project that I did in school. So this was probably done in maybe the spring of my second year for a course called Structures. So we at the college have a course called Architecture 230, which is probably somewhat similar to the course that I took when I was in school. But basically the idea with the course was you started with a rather simple plan of a building. I think in this case it was a library. And you do a basic architectural layout, which is what this drawing is. And then you do the calculations to figure out the sizing of the members. So you go to another sheet here. This is drawing S1. So this would be the first of the structural drawings. The last one I showed you was an architectural drawing. This is typical of how these look. So again, basically you would perform the calculations and you would size the members, and this is called a framing plan. You can see that down at the bottom here. It's a simplified diagram. So even though like these are, you know, actual structural members that have width, they're only shown on these drawings as single lines. We have, similar to that 3D drawing that I showed you, a series of wide flange steel members. And so any of these with the W, so these are the columns, and any of these with the W written out here would also be a wide flange member. This is a little bit different than the 3D drawing that I showed you. These are all wide flange members, no joists, but basically the concept or the manner in which these are drawn is the same. In this particular set, we did two plans. Just make sure that you're seeing what I'm seeing here. You know, a lower level plan and an upper level plan. Here is where we are seeing these joists. So it says here 22K6. That is a joist similar to what we'll be doing in our project. And the last sheet here is something called column schedule. So this particular structure for the course project was, you know, 5 stories. And what we're looking at here are the sizes for the columns at all of the intersections. So at intersection A1, on the 5th floor to the roof, I have a W member that's noted in this column here. Okay, so W here, this is W18 by 45, and it's going from the 4th floor actually to the roof. So all of these, and in your reading, you will have maybe come across a bit about how high the columns are. it's typical that they're 2 stories high. It kind of minimizes the number of joints that you would have, but also it's not so long that it couldn't fit on the back of a semi truck. So anyway, we have a column from basement to second floor, from second floor to fourth floor, and from fourth floor to roof floor. Now in our Revit project, we're not doing a building that's this tall, so just a 2-story building, just so we can sort of see all the variations of joints and conditions. But basically, I just wanted to give you kind of an overview of kind of what the responsibilities are for structural engineers and for architects in designing steel frame buildings. So in our structure, we are going to be adding columns at each of these caisson locations. So there'll be 9 columns. And similar to the diagram that I just showed you, they will be 2 stories high. And let's see here, let's go to the section. Okay. So they're going to go from level 1 up to our level 3. Now, if you recall, what we did for this structure is we designed some caissons, or we inserted some caissons, and we also did a series of grade beams that sit on top of the caissons. So there's different ways of detailing the connections between some of these structural members. This detail that we're looking at here is something that we're going to base our Revit work on. As you can see here, these are W steel columns, so you'll be using those. And this right here is a grade beam. Okay, here. The wide flange steel columns go all the way down and rest on what they're calling footing. So we're going to follow this detail. Obviously, we have a slightly different situation. We don't have this footing that's described here. We have these caissons. But we'll bring our wide flange columns all the way down, and they'll sit on top of the caisson. The grade beams are formed out of concrete, and we'll make this assumption that those are poured after these wide flange beams are set in place. Now, I'm looking at the preliminary design table that's in the textbook, and we'll do some stuff in class around this, but I did want to mention in terms of the column size, you can see here this W8 column can support up to 4,000 square feet. You only have a 2-story building, and the W8 should be sufficient for all 9 of the columns that are located in the plan. Now, of course, this is dependent on what the structure is used for. Different buildings have different structural requirements. A library, for example, like the example I showed you, has quite a heavy load that you need to design for. Books are very heavy. And so, some of the criteria that we're looking at in this preliminary design table may not apply to certain structures. But we'll just go with the kind of basic rule of thumb as a W8 being an adequate column size for the project. This detail is a detail at the top of the wall. And although what you can see here is brick, we may be using another material for our finish, but there's some similarities between our structure and what you see here. This is a beam, a steel beam. This is the joist that's sitting on top of the beam. And somewhere down the road here, at the end of this beam, it's attached to a column. That column is going to go all the way up to this level, and the beam will be framed into it. So the top of our column will be at the same height as the top of the wide flange steel beam that's here. And it's going to be minus 1.5 and 2.5, minus 4 inches at this point. Okay, so we'll come back to that momentarily.